Okay, hi, Assalamualaikum and greeting to all. In this video, we are from Group 2. We'll present about our group project for subject Hydraulic, Section 5, lecture by Dr. Nur Aliza binti Ahmad. Okay, next, I will represent you our group member, which is myself, Amir Huzaifah bin Syaiful Bahrain, and my friends Amir Syafiq bin Ashari, and also my friends Fatin Nabila binti Muhammad Rozi, and we got Haja Nurul Saidatul Adawiyah, and last but not least, our guardian is Ang Ijia.
Alright, this is our agenda of our project. So we have 7 contents to be present. First, we will introduce for our project, then we will show the objective and also the problem statement. Then only we'll move on to the methodology part, and then we'll do the result and analysis of the calculation for the original and the new design of the drainage. Then only we will discuss about the results and analysis, and last we will do the conclusion for the overall of the project. For your information, this is our case study area taken by the Gulf Pro for our flood mitigation project in Taman University by Raja Johor.
Network of structures, channels, and underground pipelines transport stormwater to ponds, lakes, streams, and rivers. The network contains both public and private systems. Stormwater drainage systems are used to collect stormwater that overflows into the road or other hard surface. Our study area in my group project is at Taman University Payung Raja at Batu Pahat. There was an existing drainage system near the main road that was 420 meters long, 1.3 meters depth, and 4.5 meters wide. The drain has an average slope of 1.7 meters. An open channel or drainage system is often made up of a secondary drainage system that is connected to a network of small drains. The major drainage system, which comprise main drains, also known as interceptor drains, and which supplies a significant percentage of the city, receive water from these little drains. The such channels utilize a trapezoidal channel shape. Our objective is make a suitable drainage system suggestion that might successfully lower the storm flow. Then, to choose the type and size of drain system that will work best for the Taman University Payung Raja drainage system. Then, to examine the flow rate between the proposed drainage system and the drainage system at Taman University Payung Raja Batu Pahat. Our problem statement is to prevent floods and heavy rain from overflowing onto the road. The drainage system was not properly planned. 2 is the size of the flow channel is improper for the area, so the stormwater drainage system needs to be properly planned.
Good day to doctor. My name is Aija. My matrix number is CF20179. Now I will continue the presentation with the methodology part. So at here, our methodology part is using the qualitative and also quantitative method, which will do some calculation to get a cubic, and also we'll find some internet resources to get the information that we needed. So at first, we'll determine the area of catchment area, which is located at the Taman University by Raja Johor. So second, we'll use the Google Earth Pro tool to get the catchment area of the site, and also the highest and lowest elevation of the drainage, and also the length of the drainage area. Then we are going for the Manning roughness. So to get the Manning roughness, we will do it by using the site visit method, which will determine the surface roughness around the drainage area, whether it is grass stain or other materials. Then we'll go for the dimension and also the area of the drainage. And here we also go through by site visit to determine type of the drainage, whether it is trapezoidal, rectangular, or other shape, for us to calculate for the area. Alright, next is the empirical IDF curve. And here we will go through from the MSMA second edition to get the nearest rainfall station, Taman University, which is Leto BPS Batu Pahat, to get the lambda, theta, nu, and also k value to calculate the equation below. Then also from the MSNA to get the RI value by determining the type of the development at the catchment area, and also the runoff coefficient also determined by looking at the Taman University, which is type of the land use that in the Taman University. So then it's a friction slope. So to get the friction slope, we'll use the Google Earth Pro to get the highest and also the lowest elevation and the length of the drainage, so we can insert into the below equation to get the friction slope. And last is the fixed flow. After we get all the values that we needed from the past slideshow that I presented, and also from the empirical IDF curve and also the friction slope, then we can sub into this equation below, which is QP equal to C times I pi A over 360 to get the cubic of the drainage at the Taman University at the same time for the new design of the drainage also.
Assalamualaikum and good afternoon to lecturers and friends. My name is Amir Syafiq Ashari. My matrix number is CF22062. Today I will explain about all these channel section. For the weight, we got 4.5 meters, and for the water weight, we got 1.7 meters. For the depth, we got 1.3 meters. And now for the slope surface, we got 3.74%. And let's calculate the water value. We got 5.39 5.39, and for the area we got 4.421 meter square, and for the Z we got 1.308. For the P we got 5.977 meters, and for the R we got 0.74 meters. And now we step 4, we must calculate the slope of overland. We got S equal to 0.005 meters. And step 5, calculate time of concentration, and we plus 5.92 plus 5.39, we got 11.31. And step 6, calculate the rainfall excess. By using the rainfall data of 100 ARI at sektor daerah TPS Batu Pahat, we got the numbers is equal to 632.407 mm over hour. Step 7, determine of runoff coefficient. We land use our site is commercial and business, and runoff of coefficient that we got 0.95. Step 8, calculate the peak of discharge, and we got, after we calculate, for the all design channel section, the peak of discharge is 7.378 the cube over second.
Okay, Assalamualaikum and greeting to all. My name is Amir Huzaifah bin Syaiful Bahrain. Okay, my metric number is CF22013. Okay, so I will present or explain about a new design of a channel section. In order to stop flash flood from happening frequently, okay, we have decide to design a new channel section by widened and deepened. Our new design for top wide is 5 meters, okay, and bottom wide is still remain 1.7 meters, but the depth for new design channel section is 2 meters. Next, we go to calculation for new design, which is we have 8 step. Okay, number 1, for calculate slope surface. Okay, we got 3.74%. Okay, and number 2, calculate Horton value, which is we got 5.39, and the calculate the area. Number 3, okay, area we got 6.8 meter square, and for Z we got 0.85, and P we got 6.95, and for R we got 0.978 meters. Okay, and number 4 is a calculate slope of overland, which is we got 0.005 meter. Okay, so for step number 5, calculate time of concentration. We got D is equal 10.343. Step number 6, calculate rainfall excess, which is we got the information from table 2.3. The answer is 658.992 millimeter per hour. And step number 7, okay, determine runoff coefficient. Okay, we got C equal 0.95. And last step, which is calculate peak of discharge. Okay, we got 11.825 meters cube per second. So as we can see, the answer for Q design is bigger than Q peak that my friends present early, meaning that the proposed new design of the new challenge section is pass. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Hajam Nusaratul Adawiyah binti Mutarudin. My metric number is CF220022. I'm going to present about discussion. From our conclusion above, we noticed that the discharge flow design is higher than the peak discharge flow, which means our proposed new design of the channel section is approved. In addition, we also found that the flow rate of each drainage size is different in terms of channel length and depth. The comparison between old and new design drainage size, for length for old design is 4.5 meter, and for the length of new design is 5 meter. For depth, old design is 1.3 meter, and depth for new design is 2 meter. Hydraulic mean radius for old design is 0.740 meter, and hydraulic mean radius for new design is 0.978 meter. Flow rate of the drainage old design is 7.378 meter cube per second, and flow rate of the drainage for the new design is 11.978 663 meter cube per second. For our project, we use Google Earth Pro, which is utilized to measure the cross-section of the drainage area to obtain relevant data using the rational method. Google Earth Pro is a computation program that generates a 3D representation of the Earth using satellite images. It offers various features like distance measurement tools, drainage analysis, and flight simulator. The selected cross-section area for this project is 292 acres, which extends the requirement of the proposed area is less than 200 acres. The managed roughness coefficient value for determined based on the grassy type of the drain with a grass cover of over 150 millimeters, resulting in a value of 0.05 meter. This allows the conclusion of the mean radius as 0.978 meter. The fraction slope of the drainage in this project is 0.004 meter, which indicates that meaning equation can be applied to estimate the rate of water flow through channels with a consistent size, shape, and slope as well as roughness. As for our conclusion is, flood mitigation is conscious of protection, society, infrastructure, and the environment from the negative impact of flood. Drainage problems such as short and narrow discharge and reverse blockage contribute to flooding in cities. The aim of the project was to develop effective strategies to minimize flood risk and build a more resilient and sustainable community. The research successfully demonstrated that the drainage in the study area had inadequate depth, causing irregular water flow during heavy rainfall. By proposing a redesign of the drainage system, the project addressed its research question and objective. That's all from us. Thank you.